In Chapter 9, we learned 3 methods for solving quadratics, so we're going to review each of the methods, and then they'll be mixed up and you can decide which method is the best in each given situation. So the first method we learned was solve by factoring. If you recall, the first step in solving by factoring is standard form, so the most important thing, make sure it equals 0 first. Okay, so if I look at A, n squared plus 4n minus 16, it's in standard form, but it doesn't equal to 0. So to make it equal to 0, I will minus the 5. If I do minus 16 minus 5, I get minus 21 equals 0. Now I can go ahead and factor it. Because it's n squared, it will be n times n. And then in your head or on the side, think about what do I times to get negative 21? And it will be a positive and a negative. What do we think? 21, 7 times 3? Positive, negative, because this is a positive 4 for the middle term, it would have to, the bigger number would take the positive. So if I do 7 minus 3, do I get 4? I do get 4. So the factors must be n plus 7, n minus 3 equals 0. And then I still need to solve it. Remember, if n plus 7 equals 0, then it must be true that n equals negative 7. And if n minus 3 equals 0, if I add 3, when I solve it, I get n equals positive 3. Okay, so for B, I'm also solving by factoring. So again, the first thing, it's got to be in standard form. So look for that equals 0. It does not equal 0. I see that minus 20, so I'm going to add the 20. Remember to add it under the like terms on the left side. And then I also need to cancel the 3i. Since it's a positive 3i, I'll subtract it. Negative 8i minus 3i is in the negative 11i. 8 plus 20 is 28. Now it equals to 0, so I can go ahead and factor it. I squared is I times I. Okay, and again, just look at the last term because that's what we focus on. Think of what you times to get 28. You can do it in your head. 2 times 14. 2 plus 14 is not 11. How about 4 times 7? 4 times 7 is 28. If I do 4 plus 7, I do get 11 because it's a minus 11. It's going to be a minus 4 and a minus 7. So that's factored form, and now I'm going to solve it. Since it's I minus 4 equals 0, I get I equals positive 4 as one of my solutions, and if I add 7, I get I equals positive 7 as my second solution. Okay, now the next method we learned was to solve using square root. So if I look at A, it says f minus 7 quantity squared equals 25. I want to cancel the 7, but I have to cancel the squared first because the f minus 7 is in parentheses. So to cancel the squared, I use square root. That'll cancel off the squared, so I'm left with f minus 7. The square root of 25 is 5, but remember, because it was squared, it could be a positive or a negative 5. And again, if you're comfortable solving it in a single equation, you can. I'm going to break it into f minus 7 equals positive 5, f minus 7 equals negative 5, and solve it that way. So for this one, f is 12 is one of my answers. F is positive 2 is my second answer, and most of the time we expect 2 answers unless there's some weird square root of 0 thing happen. Okay, for part B, e plus 1 quantity squared equals 14. This could be an irrational solution. Okay, the square root of 14, I don't know what the square root of 14 is. It's irrational. I could do 2 times 7 to go 14, but square root of 2 and square root of 7 are also both irrational. So I'm going to leave it a square root of 14, but because it was a quadratic, it should be plus or minus the square root of 14. So positive and negative square root 14. You can break this into 2 equations, or you can keep it as 1. I think most of you keep it as 1, so I'll solve it this way. If it's e plus 1, I subtract 1. This cancels the 1, and then I get e equals, and we normally put the rational part first, so the negative 1, and then the positive and the negative square root 14 is over here. And if you split it into 2 answers, you would have e equals -1 plus the square root of 14. And then for your second answer, you would have -1 minus the square root of 14. Okay, the last method we learned was the quadratic formula. Quadratic formula still has to be in standard form, so it does equal to 0, which both of these do. I'm going to identify my a, b, and c. If you forget, you can always, the formula, you can always replay that song. So x equals -b plus or minus the square root b squared minus 4ac all over 2a. Okay, let me simplify this. 3 squared is 9. Minus 4 times 1 minus 4. Minus 4 times minus 5 is going to cancel to a positive. 4 times 5 is 20. Okay, 9 plus 20 is 29, so I have the square root of 29, and then I'm going to look at this. Do I know the square root of 29? No, it's irrational. Can I simplify it? No, it's actually prime. Okay, so my answers, oh, it should be n though. N equals, because the variable I'm solving for is n. So n equals, hold on, the -3 plus or minus the square root of 29 over 2. And that represents both answers, because remember there's one with a plus and one with a minus. Okay, let's go ahead to b. B is also in standard form already, so I can identify my a, b, and c. This is x equals. Okay, x equals -b. Since b is negative, if I do -11, I get positive 11. B, put it in parentheses before you square it. Minus 4 times a times c all over 2a. Okay, let's go ahead and simplify this just like we did the last one. -11 squared turns to a positive. So positive 121 minus 4 times 2 is 8. 8 times 5 is 40. 2 times 2 is 4. Okay, let me just add up the radicand or subtract the radicand. 121 minus 40 is 81. And then before I continue, let me just stare at it real quick. Do I know the square root of 81? I do know the square root of 81, which square root of 81 is rational, which means I'm going to get some rational answers here. Okay, the square root of 81 is just 9. Okay, so now I need to consider my two scenarios here. Okay, the first one is I might have 11 plus 9 divided by 4, which would be 20 divided by 4, which is 5. So one of my answers is 5. Okay, now since it's 11 plus or minus 9, I already did plus 9. Now if I do 11 minus 9 over 4, I get 2/4. If I simplify 2/4 by dividing the numerator and denominator by 2, I end up with 1/2. So my answers were 5 and 1/2, and the answers are rational because the square root of 81 was rational. Okay, now the reason we learned 3 methods is because sometimes only certain methods work, and sometimes you have options and certain methods are easier than other methods. So for these last 6 problems, you're going to pick which method you would like to use. There's sometimes more than one method that will work, and I'm going to have you indicate which method: factoring, square root, or quadratic formula. Okay, let's look at the first one. M squared plus 7m plus 10 equals 0. It equals to 0. I personally think factoring is less work, so I normally try to factor it first. Sometimes you can think about it in your head. Let me try it before I commit. Okay, let me look at the 10. What do I times to get 10? I could do 5 times 2. Is 5 plus 2 7? It is. Okay, because I could think of the combination, I am going to factor this one. So for my method, I'm going to say I'm going to do factoring. Sometimes I change my mind after I start. Okay, but because I could factor it in my head, I'm going to do this method, which means I got m equals -5 and m equals -2. You could also have used the quadratic formula. The quadratic formula always works. Factoring and square root only sometimes work. Okay, let me go ahead and look at number 2. It's n squared plus 7n plus 4 equals 0. It does already equal to 0. So let me try to factor it. Okay, let me look at the last number. I have a 4 there, so what can I times to get 4? I could do 2 times 2. If I do 2 plus 2, I don't get 7. What if I do 4 times 1? 4 times 1 is 4. 4 plus 1 is 5. I still don't get 7. Okay, I can't think of any combination of numbers that works for factoring, so I cannot factor this. I would like to factor it, but I cannot. So this is how I know I can't factor it, when I try it and it's impossible. Because I cannot factor it, I'm going to use the quadratic formula because the quadratic formula always works. And if it can't factor, it's probably irrational, which also means the quadratic formula is easier. Okay, so n equals a is 1, b is 7, c is 4. Okay, negative b plus or minus the square root. B squared minus 4ac all over 2a. Okay, now I'm suspecting it's going to be irrational. Otherwise, I should have been able to factor it. 7 squared is 49. 4 times 1 is 4. 4 times 4 is 16. 49 minus 16 is 33. Okay, now do I know the square root of 33? I don't. It's irrational, which is the whole point, the reason I couldn't factor it in the first place. So for my n, I got n equals -7 plus or minus the square root of 33 over 2. And in this case, I had to use the quadratic formula because factoring would not work. And square root doesn't work when there's a b value. Okay, let's go ahead and try the next two. Okay, I have e squared equals 49. Well, I see e squared, and I see that squared is just asking to be canceled, so I'm going to square root it. If I square root this, the squared cancels, so e equals, and then when I square root 49, I get 7. But because it was e squared, remember, when I do a -7 squared, I also get positive 49. So in my opinion, square root was the easiest method to use here. Although because I got rational answers, I could have also done factoring, and quadratic formula always works, so I could have done that as well. Okay, now let me look at 4. Okay, now 4, depending on what you're looking at, there's 2 quick ways I see I could do this. So I'm going to do it 2 ways. You just do it the way you like. Okay, because it equals to 0, I'm thinking I'm going to factor it. Okay, so say I want to do factoring. Some of you are like, why are you factoring? I can see another way to do it, and you're going to do it a different way. It's x times x. Since this is a -4, I'm going to think of what I times to get 4. -4, so it's going to be a positive and a negative. If I do 4 times -1, 4 minus 1 is 3. 2 times -2, 2 minus 2 is 0. And remember, that's because this is the difference of squares. So if I factor, I have x plus 2 times x minus 2, and I get x equals -2, and x equals positive 2. And that was a pretty easy way to do it. But I know that some of you are looking at it and saying, why would you factor it when you can use square root? And square root's so easy. So if you think square root is so easy, you might square root this. If I square root it, I would plus the 4, because square root I solve. And then square root, and I'm going to get x equals 2 and -2. So I get the same answers, I just used a different method. So in this case, both methods were about the same easiness factor. So either method would have been fine. As long as you know which method works, you're welcome to choose either one. Let's do 2 more. Okay, let me see. For 5 and 6. For 5, I'm not going to square root it because I have this weird p thing here. Okay, so I'm going to make it equal to 0 because I know I'm going to either do factoring or quadratic formula. Okay, now from here, I can factor a quadratic formula. Personally, I would stare at it first and see, can I factor this? Okay, I'm going to write it, but you don't have to write it if you don't want to erase. In your head, think about it. Okay, it's got to be p times p if I'm factoring. Since this is -1, I want to think of what I times to get -1, which is only +1 and -1. But if I do 1 minus 1, I get 0. I don't get -5. So that's not going to work. So I actually cannot factor this because the only thing I can times is 1 times -1, and that does not add up properly. So I have to use the quadratic formula because factoring does not work and is not an option for me. Okay, so I'm solving for p, so it's going to be p equals negative b. Since b is -5, if I do -5, I get +5 plus or minus the square root b squared minus 4 times a times c all over 2a. Okay, and if it really does not factor, then normally you don't have to simplify much either. -5 squared is +25. -4 times 1 is -4 times -1 cancels to a +4. Okay, so for p, I got p equals 5 plus or minus the square root of 29 over 2, and I have no idea what the square root of 29 is. So I'm going to leave my answer as an irrational answer, and then I did end up using the quadratic formula as my method, and that was because factoring didn't work. Okay, for the last one, can't do square root because I have e squared and a 2e. So let me put it in standard form and then see if I'm going to factor it or quadratic formula it. So I'm going to minus the 15 over. E squared minus 2e. The minus 15 doesn't have anyone to subtract from, so he just gets put at the end. Okay, let me see if I can factor it before I try to use quadratic formula. I have a -15, so what can I times to get -15? 5 times 3. One of them has to be negative. Because this is a negative, the bigger number has to take the negative, so let me try that. If I do -5 times 3, I get -15. If I do -5 plus 3, I get -2. So this does factor. Let me fill in my factors, and then I will get e equals 5, and I will get e equals -3. Okay, and I happen to be used factoring for this. If you had used quadratic formula, you would have gotten the same answer, although it would have been more work because you would have had to simplify it at the end.